All right, you ready? Here's your host. You may have heard someone say that they don't trust reality, or that this world is fake news. But one thing you might not have heard is that one of the biggest research projects in the world is trying to prove that we are living inside a computer. And that's what we'll talk about today. Why do some philosophers and scientists take this idea seriously? What are the pros and cons? And how has it gone so far? Let's start with a very simple definition. The simulation hypothesis says that either we are the original base reality, or we are in a simulation run by beings like us in the future, or simulations are impossible, and therefore the only option left is that we are the real deal. There's a way to simplify this into a flowchart, which is helpful because it makes clear that at least one of these options must be true. This is how we'll proceed today. First, is it possible to run simulations? If yes, then are we running them? And third, are we in a simulation? What's surprising about the simulation hypothesis is that it's actually a fairly old idea. Some versions go back to ancient Chinese philosophy, but it was recently popularized by the philosopher Nick Bostrom. He pointed out that if future civilizations are much smarter than us and they have computers powerful enough to simulate reality, then they probably will want to use those computers. Why wouldn't they? It'd be fun, educational, and also cheaper than hiring historians to study the past. So if simulations are possible and people in the future like to have fun, then it's likely that they've created simulations, but also that they've simulated their own past. As the chart shows, that leaves only one possibility open, that we are in a simulation. Okay, fair enough. But hold on a second. I'm pretty sure I didn't sign up for a life in a simulation. Can he really just force me to accept his conclusion just because he thinks it's likely? Well, it depends on what counts as likely. And Bostrom's argument here is a probability argument. He doesn't say that there's a 52% chance we're in a simulation and 48% chance we're not. That would be silly because no one knows anything about the prior probability of simulation. But Bostrom does say that if the other two options are possible, then the second option is likely. Not that this is a slam dunk proof, but that it's much more likely than the other options. And that's how science normally works. To make things concrete, let's forget about all the talk of simulations and universes and talk about a simpler case. Suppose you're looking at a pond, and you wonder whether the fish are real or plastic. The fish are colored to look realistic, but they aren't moving, so it could be that they are inert plastic replicas. How should you think about that? Let's pretend that you have a friend who claims that some of the ponds have real fish and some have fake ones, but you don't know which is which. In this situation, it's natural to ask, well, how many ponds are there? If there are lots of ponds with fake fish and just one pond with real fish, then it's much more likely that you're fishing for plastic than for flesh. The same idea applies to the simulation hypothesis. There are different possible realities, and the probability that we're in a simulation depends on how many simulations there are. This is where the ancestor simulation idea comes in. If there are many simulations of humans in the past, then it's likely we're in one of them. But if there are few simulations, then it seems more plausible that we're in the real deal. So how many simulations are there? That depends on how easy it is to run them. Now, obviously, it's impossible to know how hard it would be to perfectly simulate human brains and bodies in a computer. But Bostrom argues that if you're worried about the computing power needed to simulate reality, then you're thinking about it the wrong way. Computing power is growing exponentially, and it's reasonable to expect that trend to continue. So eventually, in principle, you could simulate anything. At that point, it's not a question of whether you can simulate reality, just a question of price and convenience. So, given that it's possible in principle, future civilizations will probably do it anyway, even if it's expensive. If they don't, then that's just a waste of a perfectly good technology. So, in Bostrom's view, it's reasonable to assume that if simulations are possible, then they are being run. That means there are many of them. And that means we're likely in a simulation. In a recent book, though, the philosopher Hilary Greaves objects that there's something fishy about using an argument from ignorance. You're arguing that we're in a simulation because we don't know that it's possible to run simulations. She says that this is sort of like saying, I bet my goldfish are real, because otherwise you'd need a whole lot of computing power. But then someone comes along and says, actually, I can buy a simulation of goldfish. And now suddenly you owe them an explanation. Why couldn't you have figured that out yourself? Anyway, it's not just an argument from ignorance. The simulation hypothesis also faces practical and philosophical objections. On the practical side, critics argue that the energy required to run a perfect simulation of humanity would be prohibitive. We know that the total energy usage of the human brain is about 20 watts, and if you include the body, which needs energy to move around, that scales up to roughly 1 kilowatt. A simulation that perfectly models that activity would require a similar amount of energy. Now, it's obviously difficult to measure the total energy consumption of the entire human species, but a rough estimate puts it somewhere between 15 and 20 terawatts. That's equivalent to about 2% of the total power output of the sun. So the energy required to simulate us isn't infinite, but it's still an enormous amount. And this is the point. If simulations are possible in principle, then presumably they're going to be run whenever it becomes convenient. But it doesn't seem like it will ever be convenient to simulate the whole of humanity. So this practical objection says that running a full simulation is simply impossible. A related problem is that while we're good at simulating some things like climate, physics, and chemistry, we aren't good at simulating other things like human cognition and consciousness. Consciousness feels like a necessary part of reality. So if simulations are possible, but they leave something out, like consciousness, then that's another reason to think that we aren't in a simulation. Finally, there's the empirical objection, which is that the simulation hypothesis is currently impossible to test. When a scientific hypothesis is proposed, usually there's some way to falsify it, that is, to show that it's false. If there's no such way, then the hypothesis isn't scientific in the normal sense. For example, the geocentric theory that the Earth is the center of the solar system was a scientific hypothesis, and eventually it was falsified when observations of planetary motion just didn't fit the predictions of the theory. By contrast, the simulation hypothesis is currently in a sense untestable. The best anyone has come up with is to look for signs of pixelation in the sky, or unexpected anomalies, or the fact that there are limits to cosmic ray flux. But those are either not very specific, or they're interpretations of data that other scientists disagree with. None of them are widely regarded as evidence for the simulation hypothesis. In the end, if you want to know what scientists really think about the simulation hypothesis, just ask them. It turns out that most haven't given it much thought. Among those who have, roughly half say they find it plausible, and the other half say they don't. And interestingly, they tend to cluster together. People who tend to think that we're in a simulation also tend to think that it's likely that there are other simulations. And people who tend to think that we aren't in a simulation also tend to think that it's unlikely that there are other simulations. So, even though there's no consensus, there's a way to read minds on the subject. Let's close by mentioning an ethical worry that arises in some versions of the simulation hypothesis. If we are creating simulations with conscious beings in them, then should we treat them as if they're real? If yes, then it seems we should give them moral consideration. If not, then what's our excuse? They're just lines of code. If you want to know more about the simulation hypothesis, I recommend a recent overview by Nick Bostrom himself. His work is referenced below. If you're interested in seeing where this kind of thinking leads, check out a recent video called Is Reality Broken?, which talks about possible ways that quantum mechanics might break our intuitive understanding of reality. For the next minute, I'll be asking you to consider what you're doing right now and whether you might be in a simulation. Are you listening to this podcast while driving? Well, first of all, that's not very safe. Second, if you're in a simulation, the car you're driving might not exist. Or maybe you're sitting at your desk at work pretending to be focused on a task, while actually your mind is wandering over the vastness of space and time and the nature of reality. Well, even if you are at work, the desk, the building, the city, the Earth, the solar system, and the rest of the universe might not exist. Instead, you might be alone in a dark room hooked up to a machine with electrodes measuring the activity of your brain. The implication is that the stimulation hypothesis might be true, but it doesn't matter because either way, we don't know what's real and what isn't. Thanks for watching. See you next week.